Hello and welcome. My name is Fabrice Liovin. I'm part of the network division of Alcatel-Lucent Enterprise. And today I'm going to talk about enterprise network evolutions and SDN solutions. In the first part, I'll review some of the IT infrastructure transformation trends and their associated challenges for IT teams. Then I'll talk about the enterprise network evolutions and what is the purpose of a software-defined network. On the third part, we'll look if SDN solutions are really adapted for enterprise network virtualizations. Then we'll take a look at Alcatel-Lucent Enterprise solution for end-to-end network virtualization. At last, but not least, we'll review two enterprise use cases. First being SDN on how an application dynamically configures the network, and the second one being about end-to-end network virtualization by IT services with a central provisioning and management. IT organizations are on a transformation journey. It's driven by the virtualization of the infrastructure, which started a few years ago in the data center by virtualizing servers, data storage, to rationalize IT resources and deploy faster new IT services. Nowadays, users are mobile. They want to use their own devices to access data and application anywhere at any time. With this rapid evolution of smartphones and tablets, it forces companies to adapt their IT services, first to the customization of terminals and virtualization of IT services to be delivered from company premises or from the cloud. To stay competitive, business transactions must be possible anytime, anywhere, from any device. Today, for IT organizations, the priority is to have a resilient and secure network. The typical architecture is based on a segmented network by zones or areas. There is access, the core or DC, a demilitarized zone with a central firewall and routers to filter the traffic between the zones and between public and private world. In the past few years, a Wi-Fi network has been deployed, which is most of the time another network managed by its own management system with a dedicated access control and security policy. When the network is divided by zones, it is not adapted to network virtualization, cloud services, and user mobility who need to access applications regardless their location or device. There is too many bandwidth constraints between the access, the data center, and the internet or cloud-hosted services. As every connection must go through a security gateway, it creates real bottlenecks, degrading the user experience on the network. The network must evolve to adapt to the virtualization and cloudification of applications and services. Users are mobile and expect to perform business transactions using their own devices with the same experience whatever their location or time of the day. In order to simplify the end-to-end virtualization and enable cloud-based services, a software-defined network solution can be deployed in the data center. Most of the time, the existing DC network must be replaced with the latest generation of switches to support an SDN architectures and protocols. Then, the access part of the network can be unified to offer user mobility and bring your own device based on a user profiling solution. So let's look at what is a software-defined network. SDN enables the network to be presented as a set of services that the application can control. Software-defined network is a framework that provides a set of tools, standard protocols, and interfaces for application to control the physical layer. It is an independent vendor framework led by the ONF, Open Networking Foundation, that regroups many contributors from networking vendors to independent developers communities. They agree and develop open source solutions based on a well-defined architectures. Many startup companies have developed their offers and services relying on the ONF work. So on top, business application can access and use the network services via a set of API provided by a SDN controller. The controller is in charge of the control plane of the network, and on the data plane, network devices are now just forwarding devices. The forwarding decision is now made by the controller. The goal is to give applications a direct and full control of the network layer. What is the SDN solution for? Or why enterprises would deploy a SDN solution? Today, business agility is asking IT organizations to provide flexible, on-demand infrastructure services when the IT team has the ability to automate the provisioning of computing and storage resources in minutes. Still, the network requires manual interventions to deploy a new or to update Layer 2 and Layer 3 configuration. The security gateway, proxy servers, load balancers must be updated, tested, and validated before the service runs. At the end, it takes days and requires highly skilled personnel to do it. By deploying a software-defined solution, the IT team will have a tool, an orchestrator, that will present every service and network resource available in order to simplify the provisioning. From a single pane of glass, the administrator can provision the compute, storage, network and security services in few clicks only. The SDN controller connects to the network devices via a set of standard protocols to push configuration either permanently for legacy switching and routing configuration or dynamically just for a given session. For example, when a multimedia or VDI session starts, the SDN controller via OpenFlow will compute the best network path to ensure the quality of service for a better user experience. Once the session is over, network resources are released. Typical SDN solution relies on VxLAN, a new protocol that simplifies the virtualization of network services. It is an overlay protocol to enable transparent communication between VMs over any networks. VxLAN is directly managed at the hypervisor level with the vSwitch and creates tunnels between endpoints. VxLAN is the protocol to simplify the integration of an SDN solution on an existing network. Each node or endpoint can initiate and terminate a tunnel and send traffic. The traffic is encapsulated and transported by the underlay physical network. A group of VMs or an IT service can now be part of a virtual domain that spans over any LAN or WAN network. VxLAN runs on a Layer 3 IP networks, which don't need to be configured to establish tunnel. VxLAN enables the IT manager to simply provision the network connectivity via hypervisors over any existing network. It will enable Layer 2 and Layer 3 virtualization, which is perfect to interconnect public and private data centers. On the other side, VxLAN is just another VLAN technology, based on creating tunnels over an IP network. In this case, the underlay network cannot see which traffic is sent into the tunnels, meaning that no service level agreement can be set per service or application. In this case, VxLAN use high-cost computing system to establish tunnel endpoints and CPU for packet forwarding. The underlay network is still here and needs to be managed in the same way. Nothing has been simplified nor replaced. Just the VM to VM connectivity is now provisioned through the VxLAN tunnels. Most of networking and SDN vendors provide their own orchestrator and controller like VMware, Nuage Network, Cisco, Juniper, HP, and most of them relies on standard protocol, OpenFlow 1.3 and OVSDB, to program the network devices. Many open source orchestrators and controllers, such as OpenStack and OpenDaylight, are alternatives to commercial solutions, but they require system engineers with programming skills to do the integration. Network switches have evolved, and latest generation now integrates specific ASICs for VxLAN, which avoid to use computing hosts to establish tunnels, and more importantly, the network switch can now be used as a gateway to interconnect the non-virtualized servers and legacy network with the VxLAN domain. Now you can provision and manage hypervisors and VxLAN tunnel endpoint or TAP on switches from a single pane of glass. Every resources can be allocated directly from the orchestrator. But VxLAN is supported only by new switches with specific ASICs. Also, SDN and VxLAN requires new skills and expertise for the IT manager and network engineers and do not simplify the complexity of managing existing network configurations. An SDN solution with VxLAN is for the data center network and it is not adapted to campus networks, but I'll explain it in detail further in the presentation. Well, as I said at the beginning, still many enterprises are adapting their data center network to workload virtualization and cloud services. Existing DC networks are based on a 3-tier architecture, which is not ready for SAN-LAN convergence and rely on spanning tree protocol for the connection redundancy. As the traffic from east to west cross the routers on the top, the performance is rather limited, and the virtualization of a network for a group of virtual machines is really complex to achieve. So the new DC switching fabric is based on a spanning leaf design with new generation of switches that ease the convergence and eliminate the famous spanning tree by using link aggregation. It's a high-performance fabric that supports VxLAN on every port to facilitate VM mobility. The VxLAN typical usage is in the data center to simplify group of VMs layer 2 connectivity and extension of layer 2 domains across IP networks. As most of SDN commercial solutions are using VxLAN to overcome network operation complexity, many IT managers see SDN as a way to simplify the deployment of workload in the private or hybrid cloud architecture. It's easy to extend the private layer 2 domain into the cloud over an IP backbone. As I said, VxLAN is for the data center, and it is not running on the client devices, nor on the campus or access layer of the network. It is like creating a virtual network for the servers and storage without any consideration of user or device connection control and usage of the IT service. User accessing applications from the outside are not benefiting of SDN. As VxLAN uses tunnels over IP to send traffic, you cannot define QoS or congestion control by application on the underlay network. And when users are on the premises, they connect to the corporate network via the LAN or Wi-Fi, where SDN or VxLAN does not provide anything neither. It does not secure or simplify the user and devices connection to virtual domains. Also, another important point to note is that most of the large networking vendors offer two different portfolios, one for campus and another one for the data center networking, both running different operating systems with even different engineering and development cycles. At Alcatel-Lucent Enterprise, we have a different approach to answer the virtualization challenge and provide a high-performance and automated data center fabric. A spine and leaf architecture still has some limitations. First, it is limited in terms of layer 2 scalability by the number of uplinks on leaf switches to connect to spine switches, or you need to use IP forwarding to scale it up. Third, the latency for node-to-node connection is through 3 hops. And last, the spine switches are expensive and used to interconnect leaf switches only. On such fabric, broadcast, unknown unicast, and multicast or bump traffic have to be handled at the layer 3 level, as layer 2 networks or VxLAN do not handle bump traffic. It generates more complex and manual configuration of the fabric. Since few years now, we offer a pod and mesh network fabric architecture based on shortest path bridging, an IEEE standard protocol which eliminates spanning tree. It uses all links simultaneously, is extremely scalable, and simplifies tremendously the network configuration and management. Last year at Interop Las Vegas, our intelligent fabric won the Best of Show networking innovation. IFAB uses SPB to automatically interconnect top-of-rack switches, either with multi 10 gig or 40 gig links, and provides automatic virtualization configuration too. IFAB does support VxLAN, and moreover, our 6900 switches feature VM snooping, a unique ability to identify which VM is talking and recognize the application inside the VxLAN tunnel in order to adapt the QoS and forwarding path decision. Virtualization of the network layer per application or service is a key differentiator of our solution, which enables IT manager to automate the deployment of new IT service while reducing the cost and complexity of operation. Coming back to this typical enterprise network with internet and cloud on top, data center in the middle, and the campus or access network on the bottom, all being interconnected by a backbone network or one network, the first thing is to enhance the network of the data center by deploying IFAB, which simplifies the architecture the layer 2 and layer 3 virtualization and ensure the convergence of SAN and LAN. SPB is used to automatically provision the interconnection of intelligent path creation on the fabric to enable communication between VM and the gateway function with the backbone to interconnect with the cloud and other data center. When the backbone network is running SPB, then it offers a full connectivity from the access layer to the virtual machines running application servers in the data center or in the cloud. SPB enables full virtualization of the network with high performance and end-to-end redundancy for layer 2 and layer 3 VPN services. Each application or IT service is simply mapped to a virtual network domain with its own security, bandwidth and priority requirements to ensure the best quality of experience for the users and devices running application. The control and security at access is delivered by our unified access solution, which automatically assigns devices and users to a universal network profile. Then this network profile is mapped to a service on the backbone using ISIS to calculate and establish the shortest path between source and destination. It is what I call end-to-end virtualization, where from the access to virtual machines, the connectivity is established through a secure and isolated virtual domain provisioned automatically on the access and backbone of the network. Security of a virtual domain and moreover virtual machines is critical. An SDN solution should provide ways to simply provision and manage access control and firewalling services. Most of the SDN vendors offer what I call a super vSwitch, which extend the function of the Hypervisor basic vSwitch to enable filtering and advanced networking function between VMs. The issue is that the network management system doesn't manage the vSwitch in the host, then it is very difficult to have an end-to-end provisioning and monitoring of your virtualized IT service. Our solution uses EVB or Edge Virtual Bridge. EVB is a standard supported by host network interface card, hypervisors, and our top-of-rack switches. It enables the hypervisor to delegate the inter-VM's traffic to be handled by the top-of-rack. Instead of using a vSwitch that consumes CPU and RAM resources of the host, it's better to let the top-of-rack switch do the heavy lifting. So either you buy an extra license for an advanced vSwitch, or you can use an EVB top-of-rack switch and benefit from its advanced networking and security features. So when the IT manager creates a new VM, he can define a security policy, the QoS, and VLAN that is mapped to a virtual network profile or VNP on the top-of-rack switch. Each VNP corresponds to a virtual network. You can also reinforce the security while simplifying the provisioning with a Radius server that will authenticate the VM and put it automatically into the defined network profile. IFAB goes further and will create automatically the end-to-end virtual network service based on the VM application. The VNP is used by SPB to provide layer 2 and layer 3 traffic containment up to the access switch where the device connects. Our new OmniVista management platform greatly simplifies the end-to-end virtualization management and provisioning of the network. OmniVista Virtual Machine Manager, VMM, enables the end-to-end provisioning by binding the hypervisor managers, vCenter or SCVMM for example, with our network profiles. As I explained before, most of SDN solutions propose an advanced vSwitch to allow the SDN controller to have a complete control of the traffic between VMs. OmniVista binds hypervisors and VM manager with our network switches to automate the end-to-end provisioning of an application to a virtual IT service on the network. The IT manager can map an application to one virtual network which will be translated to a VNP. As soon as the VNP is created, it is distributed to every top-of-rack, and when a VM starts sending traffic, the switch will automatically put the VM in the right virtual network, and SPB creates the network service at the layer 2 and layer 3. VMM offers an important set of tools to locate and move VMs, monitor resource usage, security policy, and provide application visibility. Our switches that support deep packet inspection and VM snooping will give the IT manager a new level of control of what application and user are doing on the network. You can better control the traffic per virtual domain. For example, if you have one virtual network for one type of IoT, you can enforce that only this type of connected device is able to connect and generate traffic on the network, then reject any kind of traffic which is out of this IoT application. This first use case is based on an SDN solution with a NEC SDN controller that use OpenFlow to program and control the network for an end-to-end multimedia session. NEC SDN programmable flow solution is one rare solution on the market that do not use VxLAN and really replace the control plane of the network switches. What we want to achieve here is three things. First, dynamically establish a network connection path with guaranteed bandwidth between two users to ensure the best quality of service and experience. The second one is more from a server side to be able to dynamically assign resources based on the level of demand. Here, there is a cluster of a Skype for Business server on one side and a backup cluster on the other side, which can be triggered automatically. It means that the System Center platform can dynamically define which VM will be used per session. And third, the SDN controller will dynamically configure the network switches, or 6900, to guarantee the bandwidth with the right priority level for the duration of the session only. The SDN controller is programming the network path for the session connectivity using OpenFlow 1.3 and monitors the session traffic. The second use case is an example of an IoT network containment on a university campus. The network is virtualized by user and IT service, one network for faculty user, one for student, one per type of device. To connect securely user and devices onto the network, our unified access solution enables single access control policy provision on the LAN and wireless LAN at the same time. OmniVista will push the universal network profile on every access switch and wireless LAN access point, and IFAB creates network services throughout the entire network. In the data center, our pod fabric enables VMs to be moved while serving the IoT or university users. Each virtual network spans from the access port to the top-of-rack switch in the data center. Wherever the user or device connects to the network, it will be pushed into its container and the traffic will be enforced according to the quality of service and security policy defined for that virtual network. OmniVista controls and manages the creation of container, and with VMM, it enables the IT manager to simplify the connectivity of virtual servers in private or public cloud. Now, let's review the key points of an SDN enterprise solution as presented here. First, most of SDN solutions on the market today use VxLAN to simplify the provisioning of Layer 2 virtual network service. VxLAN has been designed for data center and it is not supported on access or campus networking devices in general. You need to have a single pane of glass or an orchestrator to simply provision compute, storage, network and security resources. Our IFAB solution use SPB, which is a carrier-grade multi-tenancy standard networking protocol to deploy Layer 2 and Layer 3 virtual network services. SPB is highly scalable, up to 16 million of nodes per network, and provide advanced control and security services. At last, but not least, our OmniVista Virtual Machine Manager module is an Hypervisor agnostic tool which binds the network with computing, storage, and security virtualization. And on top, OmniVista Application Visibility module gives a complete visibility to manage the quality of service per application down to the user level, and with its smart analytic tool, you can predict the future and IT resources needed per IoT or new IT service growth. When enterprises are looking to simplify the provisioning of the network and reduce time to provide new IT services, most SDN commercial solutions are not adapted to the access part of the network and do not replace or simplify legacy network operations. To summarize my presentation, today IT organizations are looking to extend the virtualization and convergence of IT services onto a single infrastructure which is fully virtualized from computing to storage and network services. It means reducing the time to deploy a new service and simplified maintenance operation. As users are mobile and application servers run on virtual machines, it is key that the network device provide a strong security access control capabilities while enabling the network mobility. SDN solutions for enterprise based on VxLAN are limited to the data center or virtual machine connectivity. User devices or IoT are not supporting VxLAN, which forces the network team to statically provision and maintain a configuration on every single access port and wireless LAN access point with many different tools and security measures. ALE solution is based on a distributed intelligence in the network devices with central provisioning and management with a set of API to be connected to virtualization management platform. Our awarded innovations, unified access, intelligent fabric, and application visibility are designed to simplify an end-to-end workflow management from the user and devices up to the cloud-based application services in order to deliver a better quality and simpler experience. Thank you for listening to this presentation, and I hope to see you again soon.